Hello class, welcome back to our YouTube channel, and for today's discussion in statistics and probability, we have the lesson 7, which is converting a normal random variable to a standard normal variable, and vice versa. So for today's lesson, we have these objectives. The learner will be able to distinguish a raw score and the standard score, or X and Z. Express normal random variable as standard normal variable. So express X as Z. And also express standard, which is Z, as normal random variable. And lastly, apply these concepts of normal and standard normal random variable and standard normal variables in solving real-life problems. So previously, we already discussed what is a normal random variable. So it is also called a normal distribution, which has an illustration of a normal curve. So that is the bell shape. So for today, we are going to further apply it to real life problems. So how can we do that? So that is through the process of standardizing or standardization. Again, this is the process of converting a random variable, which is the X, to a standard normal variable, or the Z-score. So we already tackled the Z-score, that is that can represent a certain area of a region under the curve. So this standardization will be having the standardized value, which is also called as the Z-score. So what is this Z-score? The Z-score is a measure of the number of standard deviations of a particular data value that is away from the mean. So we have the mean from the center, and a multiple of standard deviations will be added to the mean to the right and will be subtracted if it's to the left. So we're going to have an illustration of our Z-score from this example. So let's have this example problem. The score in a test in statistics and probability is 39. And the scores are normally distributed with a mean of 33 and a standard deviation of 3. So we have here a given scores, which is the X, and the mean, which is our mu, and the standard deviation. Now, let's try to illustrate it. So we have here the normal curve, or a normal distribution with a peak value, middle value, which is the mean. So our given mean in this problem is equals to 33. So from the mean, which is 33, we're going to add and subtract, add values, which is a multiple of the standard deviation, 1, 2, 3, and subtract also if it's going to the left. So we have here 33 as the mean. So we'll be having 33 plus, first to the right, 33 plus 1 multiplied by the standard deviation 3. So this is 33 plus 3, which is 36. And 33 plus 2 times 3, this is 33 plus 6. This is the score, or the 2 standard times standard deviation, is equals to 39. That means that is our given score. So this this 39, the score 39 is placed to this location, which is the second multiple of the standard deviation to the right. So let's continue. 33 plus 3 times 3, that is 42. And to the left, we are going to subtract the multiple of our standard deviation. 33 minus 1 times 3, that is 30, equals to 30. And 33 minus 2 times 3, so 6. 33 minus 6, we have 27. And lastly, for multiple of 3 to the left, we have 33 minus 3 times 3, so 39. We have 24. So this is a sample illustration of our scores. So this is our converted scores to the Z-score. So these values here to the horizontal line is also the Z-scores, and the converted value is the scores, or our X. Now we are going to discuss how can we convert the X value to Z-score, or also called as standardized value. So first, we need to subtract the mean from your X, which is the given score. Second, divide this quantity, or your difference, X minus mu, by the standard deviation, given standard deviation. So we have the formula Z, the Z-score, equals to X minus mu all over standard deviation. So our Z here is the standard normal score, or the Z-score. X is any value, any score, and the mean is the mu, and sigma is the standard deviation. So let us apply the conversion, the process of converting or the standardizing, in some of our examples here. So let's have example 1. Suppose IQ scores are normally distributed with a mean 100 and standard deviation of 10. If your IQ is 85, what is your Z-score? So we have given values: mean, which is equals to 100, standard deviation, which is equals to 10, and X, which is 85. So we are going to find the Z-score, find Z. So in here, we have X minus mu, Z is equals to X minus mu all over standard deviation. So we have 85, which is our X, minus 100 all over 10, which is the standard deviation. And we have 85 minus 100, that is equals to negative 15. So do not forget your negative value if there is a difference which is negative, because this will determine the sign of your Z-score, if it's to the left or to the right. Positive values to the right and negative values to the left. So we have the standard deviation, or the denominator, 10. So negative 15 divided by 10, that is equals to negative 1.5. This means that our Z-score, the Z-score of your IQ, which is 85, is equals to negative 1.5. So when we're going to plot it in the normal curve, so your 85 score will be placed in the Z-score negative to the left side, which is 1.5. Example number 2, we have on a nationwide placement test that is normally distributed, the mean was 125 and the standard deviation was 15. If you scored 149, what was your Z-score? Again, we are going to find the Z-score here. So given we have mean 125, 15 standard deviation, and 149 rather, which is the score in a nationwide placement. So find the z. So for the solution, we have the formula again. Z is equals to x minus mu all over standard deviation. So we have x, or the score, or the placement score, which is 149, minus 125, which is the mean, all over divided by 15. So 149 minus 25, that is equals to 24, divided by 15, that is equals to 1.6. So this time, our z-score, the z-score with that is converted from a score of 149 is equals to 1.6. 1.60.